In our work, we look at how narratives and gamification can be used to foster development of visualization literacy skills in young children between 11 to 13. We present our own instance of such a game, evaluate it in a between-subject study, and report results. We also detail key design considerations for future visualization-based games and highlight many opportunities for future work.
Studies in HCI follow similar steps in explaining hypotheses, laying out a study setup, and reporting results. Many of these decisions are buried in dense scientific text. We contribute a set of examples of how data comics support that reporting, providing an initial set of concrete ideas for how to communicate common stages of HCI studies and statistical analysis.
What is insight? It is a question that has bothered visualization researchers for a long time. We're wondering whether visualization practitioners think about data insights in the same way as visualization researchers do. So we interviewed 23 visualization practitioners to understand how they think. To find out more about what we found and the implications to the visualization community, take a look at our paper.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau, answer questions at the speed of thought.
Usual collaborative systems propose a public and private environments, the latest possessing visibility rights. Subjective views are special objects perceived differently per user. However, a break in the social space may happen during exploration. Our visualization context strives to link efficiently multiple related visualizations together around a common object. We discussed about the designs of a stacking layout, virtual linking layout, and a mix between them.
We propose a localized approach to topological simplification called LTS, which computes the exact same result as the current state-of-the-art simplification procedure implemented in the topology toolkit. But LTS is an order of magnitude faster as it utilizes shared memory parallelism and constrains computationally expensive procedures onto small subsets of the domain. This approach significantly accelerates an essential part of topological data analysis pipelines.
Typical e-ink displays are in black and white. With the absence of color, we explored texture encoding as an effective way to visualize data. Inspired by existing practice, we summarized black and white texture properties, which can be used to encode data. We developed a prototype of a design tool that can customize black and white textures by manipulating these properties.
In this work, we present an atmospheric model tailored for the interactive visualization of planetary surfaces. Our model provides a complete framework for the absorption of light by small and large particles, such as the oxygen and ozone molecules and Mars dust particles. We demonstrate our results using Earth and Mars as examples.
Ensuring the usability of a dataset is often tied to data wrangling. We can use provenance to log the employed steps, but these alone will not give us meaningful insights if data quality was improved. We propose to incorporate data quality metrics into the provenance model. The enhanced provenance graph can be visualized to show the development of quality throughout the wrangling process. To find out more about the visualization design and the results of our evaluation, please join us during the live presentation and discussion session.
Rendering large volumetric datasets is still a challenge for real-time applications. Wouldn't it be nice if you could just render the dataset at a low screen resolution and your neural network upscales it to the full resolution again? We proposed a network architecture that does exactly that and can outperform a full resolution rendering for large datasets. For quantitative and qualitative evaluations, come to our talk.
Hey everyone, I'm Junhan Zhao, PhD candidate at Purdue University, computer graphics major, and presenting our recent research outcome, ThinksMap, an abstract approach to visualize 2D spatial distributions. Due to the conflicts between the limitation of display area and the large amount of comparative distributions need to visualize, the current methods are always restricted. These observations encourage us to come up with a solution by abstracting the visualization.
As visualizations begin to use color, shape, line, and form in new ways, legends often go overlooked as essential to interpretation. To address this issue, we created a web-based interface that renders and formats legend entries, presenting the dynamic properties of glyphs, lines, and surfaces, and increasing nuanced object recognition in artist-driven 3D scientific visualizations. Each legend entry includes the variable name, full value range, and artist-chosen artifact.
Researchers use Argus to determine the sample size based on estimations. There exists a non-trivial dynamic relationship between those estimations and the statistical result and power. Argus allows researchers to explore scenarios of experiment design and effect sizes to better plan experiments.
Atmospheric convection is one of the most important phenomena in meteorology. It is responsible for cloud formation and storms. Yet, the measurements of the convective processes are expensive and scarce. In Isotrotter, we collaborate with a domain expert to build an empirical model of the atmospheric convection based on paragliding data. We design a novel visual parameter space analysis technique using isostructures in the parameter space to explain and validate the model.
Large displays are beneficial for visualizing vast amounts of data. However, there are challenges regarding perception, personalized views, and managing data complexity. To address these issues, we propose to combine large interactive displays with personal augmented reality. We present a design space, as well as several visualization techniques, such as curving the whole screen, embedded visualizations, and many more.
Hi, please come see our talk if you are curious about how to encode your data so that it can be efficiently queried later at different fidelity levels by fetching only the relevant bits from the disk. The talk is titled Efficient and Flexible Hierarchical Data Layouts for a Unified Encoding of Scalar Field Precision and Resolution.
To generate a visual data story, one needs to learn a lot of techniques such as data analysis, visualization, and scripting. To lower the technique barrier, we introduce an intelligent system, Calliope, to generate visual data stories directly from an input spreadsheet in a fully automatic process. Using Calliope, a good visual data story is just a click away from us.
Nowadays, technology is developed for a single audience, assuming that one size fits all. Nevertheless, we all have individual differences such as personality. Taking into account how personality affects preferences, we study whether it has an effect on hierarchy, evolution over time, and comparison contexts regarding information visualization. We leverage all personality variables from the 5-factor model and the locus of control with correlation and clustering approaches, showing promising results.
Approximately 100,000 cases of head and neck cancer are diagnosed in the US annually. Patients are increasingly likely to survive but often experience acute and long-term side effects. Hence, great importance has been placed on improving patients' quality of life and reducing symptom burden during treatment. Using novel visual encodings, we introduce an interactive system which enables clinicians to assess medical data, providing context for new patients based on clinical features and symptom evolution over time.
We present an investigation.
Urban motion, illustrating the movement of population from billions of sparse trajectory records. Chang'an Avenue correlates with movement flow, the regions with the largest flow volume. Zoom into the region The southern Huilongguan region is mostly in blue, cut by G6, which could account for its commuting.
Hello, everyone. Welcome back to VizSec. I'm Lane Harrison. I'm co-chairing this next session with Steve Gomez. So we have coming up now network analysis and incident response, and also some good practitioner talks. So I hope you're ready for the next round of papers. First up, we have exploratory analysis of file system metadata for rapid investigation of security incidents, and that presenter is going to be Radek Ošlejšek. So Radek, I think you're up next.
Hello. Security incident investigators work with many data sources like system logs, network traffic data, or data from storages. Regarding data storages, analysts can deal with either complete disk images or with snapshots of file system metadata. Full disk images provide exact copies of storage devices with complete content of file, but they are huge, typically several gigabytes or terabytes. This is why forensic investigators prefer snapshots of file system metadata that provide only limited information because no content of files is available, but they are reasonably small, and at the same time they provide sufficient information for the investigation. Let's show it. File system metadata captures the last manipulation with files. In this box below, there is an example for SSHD binary file, but the whole dataset consists of similar records for each file or directory on the disk. In our example, the last manipulation with the SSHD is captured by 3 records using 4 different attributes, MCB and A time. The modification time attribute captures the last modification of the content. So we know that at this time somebody wrote to a text file or compiled a binary. As you can see, our file was created at this time, so at this moment the package maintainer probably compiled the binary. The change time denotes modification of access privileges or ownership. Birth time, birth time denotes when the file was created or replaced on the disk. In our example, both these changes were done at the same time, which means that the binary was installed or replaced on the disk. If the order was reversed, the binary was installed first and then modified without replacement, then it would be really suspicious and worth paying attention to, because it would indicate that somebody changed the content of existing installed executable. The access time captures when the file was last read without any modification or when a binary was last executed. Even this simple example demonstrates that the interpretation of the metadata requires deep expert knowledge, and the exploration of suspicious records has to be done in the context of other modifications that are captured in the dataset. And providing support for such visual exploratory analysis was the goal of our research. The dashboard consists of 3 coordinated views, where a change in one view to the dataset affects other parts of the dashboard. The primary part of the tool is in sector 8 that handles list of metadata records. I switched to video to demonstrate interactions. The analyst can easily skip blocks of records with respect to a given prefix. By selecting a user shared doc prefix, for instance, we can skip back and forth to the previous or next directory. The same principle works also for timestamps, where we can skip by year, month, hour, and so on. Records can be highlighted or even filtered out temporarily as well. As the list displays only a limited number of lines, the current
span is reflected in the upper timeline in the form of sine stripe. If the analyst scrolls up and down, then the stripe updates accordingly so that we know what part of the span is actually displayed on the screen. The upper part of the dashboard provides an aggregated view of timeline. It consists of bars denoting the number of available records spread over time. If we zoom in or out, then the timeline automatically switches its granularity from years to months, weeks, days, and so on, and the bars are recalculated accordingly. Details of bars are provided on demand as tooltips. By clicking on bar, the list scrolls to the beginning of the data. Records of high importance can be bookmarked in the list view. After that, they are emphasized in the list and displayed in the histogram as pushpins. Pushpins that are too close to be shown separately are merged into a single symbol with the number of such aggregated pushpins. Because bookmarks represent key records for the evidence and provide important context for the analysis, then they are always presented in the list of records, even if they would be potentially hidden by filtering, as I will show you now. Filtering is possible on the per attribute basis. Individual attributes are represented by different colors in the histogram. Another filtering is possible with respect to time windows. Several spans can be drawn and managed in the histogram. They can be easily shrinked or strengthened by days, weeks, and so on to provide narrower or broader context. The analyst can focus on selected time window, directly manipulate with them, and so on. The third part I'd like to introduce consists of so-called clusters. Clusters represents a generic mechanism enabling analysts to select files or directories with a specific like fingerprint. They are defined by the combination of file system attributes and location in the file system. Together with domain experts, we predefined several clusters that we suppose to be useful, like privileged executables, hidden files, or files denoting compilation signs, but it's possible to define new clusters as well. Currently, only one cluster can be applied at a time, but we already work on the version where the combination of clusters will be possible. When a cluster is selected, then the list of records is filtered with the exception of bookmarks that are always preserved, as I already explained. The number and stripe in each cluster indicate how many records are available in the dataset fulfilling the cluster criteria. This is the higher number versus how many of them are actually available in list view with respect to other filtering options like the span restriction, for instance. Therefore, the analyst can glimpse the impact of each cluster very quickly and prioritize the usage of clusters according to the number of related records, for instance. To prove the usability of our tool, we invited 5 professionals who work in the cybersecurity domain, but not all of them had experience with directly with analysis of file system metadata. So we covered both experienced and less experienced users. We used a real incident with quite typical attack vector, but with individual pieces of information hidden in the amount of data and not really easily observable. Analysts have never seen the tool, nor the incident of course, therefore we familiarized them with the interface first, which took roughly 20 minutes. Then they analyzed the incident, aiming to summarize what happened and when, in their words. We restricted the analysis phase roughly to 1 hour, wondering how much information and in what detail they would be able to provide. And we were quite surprised. First, we evaluated generic usability using standard system usability scale method. The final score 88.5 indicates excellent usability of the tool, which is great.
We also tested precision of the investigation results. The attack scenario is summarized in the upper box in the form of 6 stages that we observed in the data. It's as follows. The attacker used the account Martin to get in remotely by SSH. Then he installed a Trojan code to the system by changing system configuration and one system library. Then the attacker compromised also the account of user Roberto, probably as a backup entry point. The attacker probably was not satisfied with the Trojan code because he recompiled the code on the host and reinstalled it. He also created a hidden directory where he compiled suspicious tools and where he stored results of massive network scans. And finally, the system accounts were modified. Probably a new user was added. The bottom table summarizes how much the analysts were able to observe these 6 steps. The black circle means fully observed step with sufficient details. White means overlooked step, and black and white circle denotes for a partially described step. After the real investigation usually takes many hours or even days, and our respondents were limited to only 1 hour, the table clearly shows that still they were able to recognize most of the attack scenario, often in very surprising level of details and precision. The only problem they faced was with the 4th step, which was the recompilation and the reinstallation of Trojan code. To get even better insight into the usability, we used a simple easy question evaluation method where the analysts rated how much the tool helped them to solve 6 particular analytical tasks that we identified together with domain experts and which were part of the investigation process. They considered the investigation of suspicious files, privileged executables, the usage of unusual commands and possibly compromised users as very easy with our tool. The identification of system files probably modified by the attacker was ranked as rather easy, and the only identification of executables that were not installed from its package was considered difficult, which pretty corresponds to our previous results where this step in the attack was overlooked by most of the analysts. During the evaluation, we noticed that the users significantly differ in the way how they use the tool or in general in their investigation strategy. Therefore, we explored their interactions that we recorded and measured how much time they spent by using 5 major visual or interaction artifacts. Filtering by name, by span window and attributes, and using clusters and pushpins or bookmarks if you like. As you can see, all the analysts preferred the combination of only 2 or 3 artifacts that they used intensively and mostly overlooked other features. But we didn't recognize any pattern like that there would be some preferred combination or combination that would lead to better results or something like that. Anyway, this observation suggests that our tool doesn't restrict analysts in their investigation strategy, but still significantly help them in the investigation, which is great. The results of the evaluation convinced us that the tool is easy to use and is useful. The analysis is efficient even when conducted by less skilled analysts. However, we also got a useful feedback and ideas for further improvements. For example, we noticed that multiple analysts forgot to cancel the per attribute filtering during the investigation, which led them to false hypotheses and then delays in the investigation. Therefore, some kind of better indication of these filters is required. Another point is related to bookmarks. Current bookmarks are
represented as pushpins, and they are very simple and used primarily for fast navigation. But multiple analysts were asking for the possibility to distinguish between them by color, tagging them, making their own notes, searching in bookmarks, and so on. This change from simple bookmarks to something like advanced annotations would be useful for the automatic generation of incident reports directly from the exploration process. That would shorten the time for investigation. File system metadata represents only one source of information, especially so-called super timelines that combine file system metadata with system logs are often used in forensic analysis. As both file system metadata and system logs represent time series, then the extension of our tool would be possible and valuable. However, further research and evaluation are needed in the future work. Okay, that's it. Thank you for your attention, and I'm ready to answer your questions.
All right, thank you very much. Clap, 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 clap. So thank you, Radek. I do see some questions popping up in chat here. They're getting covered by the clap, so I'm going to go ahead and ask them before they disappear. From Steve Gomez, I see, are there specific threat models the tool is aimed at helping investigate, or is it more general?
It's general. We designed this tool to be really general, and the evaluation proved that it supports different let's say, investigation strategies. Of course, we tested it on one specific incident, but we are pretty sure that it's general, and multiple threat scenarios are explorable by this tool. Yeah.
Gotcha. Just a quick follow-up, because I've been thinking about threat models as well. Do you think that maybe defining specific threat models could help maybe determine features in the future, or even use cases, perhaps?
Yeah, we would like in the future, we would like to analyze how the users use individual visual elements of our tool, because it seems that there would be some analytical strategies that would be classified and inferred from this analysis. So it looks to be very interesting for future. Yeah.
Awesome. Okay, so second question that I see from Jan Zalauka. Did the users have a warm-up, or did they start the investigation right away without previous experience with the system?
Yeah, they have no experience with the system, so we introduced them the tool on dummy data for roughly 20 minutes, and then immediately they investigated the incident.
Awesome. All right. Well, thank you so much. I think this puts us right at time. I also have questions, so I might follow up offline. But thank you again, Radek. Cool paper.
Thank you.
All right. So next up, we have improving interpretability for cyber vulnerability assessment using focus and context visualizations. That's going to be presented by Kenneth Alperin. So Kenneth, I think you're up next. We'll play yours.
Everyone, my name is Kenny Alperin. Along with Allan, Wollaber, and Stephen Gomez, I research cyber analytics and operations, and we appreciate the opportunity to present our paper to you today. I will be talking about our work in leveraging recent advances in interpretability and explainable AI towards creating visualizations geared at cyber operators who conduct vulnerability assessments. In this talk, I will present work toward more interpretable cyber vulnerability information using visualization. To start, imagine you're a network security analyst who is responsible for reviewing vulnerability scans of your network and planning how to patch issues.
Some of the key tasks include characterizing structure across vulnerabilities, which we'll refer to as CVEs, evaluating the impact of individual CVEs, and understanding how features of a CVE description might be predictive of exploitation risk. Together, these steps help cyber stakeholders plan for near-term responses and potential future threats. In this video clip, we see one way that a defender might access CVE info through the National Vulnerability Database web portal, also known as the NVD. Portals like these were designed to see trends at a different scope than cyber defenders. Therefore, we wanted to provide displays more targeted to this group. Now, along with the CVE description, you might look for a numeric score for the vulnerability to understand its estimated severity, in particular the CVSS score, which gives a quantitative way to compare vulnerabilities. However, trusting the summary severity score, when many factors influence it, can require trust in a somewhat obscure system. You can read our paper to learn more about how CVSS works and some of its interpretability challenges. In addition, risk scoring approaches that use machine learning rather than curated formulas have similar transparency issues that hinder interpretability. To address a bunch of these issues, we presented a study in designing interpretable analytics to help analysts better understand vulnerability reports and scores at both contextual and detailed levels. From our study, we have 3 key contributions in the paper. First, we show an overview-based visual analytic of vulnerabilities using clustering of natural language features in descriptions that provide context about relationships of CVEs within the NVD. Next, we demonstrate the feasibility of an explainable AI toolkit to produce local model explanations for predictive vulnerability analytics. And lastly, we present a simple application of polar area charts for CVSS vulnerability scores, which could help defenders triage vulnerabilities more effectively at a glance and down-select the candidates to address. Our contributions build on recent work in visual analytics and operational cybersecurity. We aim to address risk interpretability issues, such as the one identified by Alodi et al., that decision makers may not be incorporating all useful information about the likelihood of exploitability, not just impact, when it comes to planning. In our context and focus visualizations, we build on visual encoding ideas like the CVSS representation in Vulnus, which aim to help in mitigation planning and other CVE feature visualizations. Finally, at a high level, we want to improve trust in machine learning applications and cybersecurity, which Gove et al. Discuss, and provide an initial demonstration of explainable AI concepts specifically for vulnerability data. Here is the agenda for the talk. I just covered the background and related work. Next, I will go into the different visualizations we created for interpreting vulnerability assessment, starting with developing a top-down view across the NVD. Then, I will discuss the focused view visualizations we created for interpretability for specific vulnerability scores. For the rest of this talk, when we mention a machine learning-based risk score, we consider models that try to predict inclusion within exploit threat profiles based on features we can extract from CVEs. We want to interpret these outputs in addition to conventional scoring systems like CVSS. Here is the machine learning pipeline we developed to demonstrate the analytics on both the top-down and focused view levels of abstraction. In total, there were over 136,000 CVEs in our corpus, and we used threat profiles as labels for whether or not each CVE has an exploit in the threat profile. In the lower right Venn diagram, we show that not all CVEs that have an exploit are represented in different threat profiles, including ExploitDB, exploits posted on GitHub, and Metasploit. We wanted to understand the relationships between the features that might be exploited in one profile versus another in a big picture view, and that motivated the next visualizations that you will see. Now I will discuss our work towards interpreting the NVD from a top-down view. We expect that a top-down view of the CVEs in the NVD or other vulnerability repositories could reveal trends at a global level into what an attacker might exploit. At this scale, our goal is to support insights about trends in CVEs with respect to specific threat profiles like threat actors or exploit sets. The paper discusses more about how the threat profiles are made, but they can either represent a particular adversary of interest or an exploit set, as you saw in the previous slide.
A key consideration in comparing the different profiles is the high dimensionality of the feature space, given the number of unique terms across the NVD corpus. Dimensionality reduction allows for removing noisy aspects of the data and making the most important structures interpretable by people through visual encodings. We selected the T-distributed stochastic neighbor embedding, also known as T-SNE, to perform this visual encoding of CVEs, then compare them across different profiles. T-SNE was selected over other methods because it has been demonstrated as an effective technique in text analytics, it has succeeded at preserving local structure in the data, and it is well supported across data science toolkits. We implemented T-SNE based on the machine learning pipeline shown earlier and generated the visualizations here for different threat profiles. For each profile, we colored the CVE according to the risk score generated by the ML model, with 0 encoded as light yellow, 1 encoded as dark red, and values between them linearly interpolated on the color scale. T-SNE is designed to preserve distance between data points. Often, it can take a while for information about a new CVE, such as known exploits, to be released. Given a new CVE and being told it looks like one that needs to be remediated, we can place the CVE on the T-SNE plot and note whether it is considered similar to risky CVEs in each profile. This gives more context to the CVE in relation to others. One area of future work we have is to explore downsampling of CVEs by criteria such as the platform or software service before dimensionality reduction. This can make the visualizations easier to read since there are fewer data points and have an improved signal-to-noise ratio. This also may help to observe trends at a smaller level by showing clusters of vulnerabilities for a particular software service, which could help a cyber defender observe risky vulnerability characteristics for that service. Now, I will discuss our work towards designing focused views for interpretability of both CVE risk and severity scores. To provide a more detailed view of ML-based scores for a specific CVE, we set out to illustrate what CVE features the scoring model bases its decision on. Scores with no additional context are difficult to interpret and prioritize for defenders. They will not necessarily have a full understanding of how an ML model works, its limitations, or historical accuracy. Considering that a network or host can have many vulnerabilities on it, especially since backlogs of unpatched vulnerabilities are common, it is critical to provide additional context to a defender who needs to decide what to next address. This motivated us to explore XAI techniques for machine learning-based risk scoring to provide details on demand for cyber vulnerabilities. Trade-offs of different XAI techniques need to be considered in terms of speed and model type for our problem. Current XAI techniques can be model-specific for one type of machine learning model, or model-agnostic for any type of machine learning model. Because we wanted to display additional context to a user who needs to make timely prioritization decisions, we chose the LIME algorithm due to being fast, model-agnostic, and easy to use. LIME constructs models around each prediction to locally explain how the machine learning model made that particular prediction. While it's not as exhaustive as some other techniques such as SHAP, it is much faster. Here is a sample output of LIME for a particular CVE. LIME allows us to understand which features influence a machine learning prediction. We first see the CVE risk score as the probability the CVE is in the exploited class on the top left. The CVE description is displayed with certain terms highlighted by what class they drive the prediction towards. Lastly, on the right, a diverging bar chart shows the amount terms influence the end score. LIME outputs for different threat profiles can be compared alongside one another. That is discussed further in the paper. Being able to generate the explanation is independent of the machine learning score, but the hope is the explanation helps to understand cases where the machine learning model is correct or wrong. One shortcoming with using LIME is that it only analyzes individual terms. It currently does not support multi-word phrases. In the paper, we developed a diverging bar chart of latent semantic analysis topics, as shown on the right, to get at the higher-level concepts related to a CVE. We'd like to extend this visualization as future work with both further refinement and validation. Even though ML-based risk scoring is becoming more common,
Some tooling and operators continue to rely primarily on the common vulnerability scoring system, severity scores, to conduct vulnerability risk assessments. Our hypothesis is that providing analysts with a simple visualization that explains how each component contributes to the total score will help them prioritize vulnerabilities to mitigate. In addition, letting the analysts interactively prioritize score components based on their own environment will help them understand and prioritize vulnerabilities tuned to their network. Having the formulas for the severity score doesn't make it obvious how much each of the subscores contributes, so we came up with a regularized score and visual encoding that show the contributions of these subscores in a more explainable manner. So a user doesn't need to parse the CVSS standard to gain insight into what the scores mean. For this visualization, we knew we wanted a radial plot since it is space efficient in a dashboard that we envision an analyst using our visual encodings in, and therefore we first looked at radar plots before arriving at polar plots. In the lower right-hand corner, we show an example of both of these. There are known problems with the radar plot in terms of people interpreting the area in between the axes, and polar plots improve on this. Therefore, we selected polar plots because of their space efficiency and ability to compare shapes between plots quickly. Here's a set of polar plots for a few CVEs. The plot shows a set of wedges which represent the contribution of each feature towards the overall CVSS score. These are features that CVSS uses to combine into the final score, which is used to color the plots. One thing to note is all three of these CVEs have the same CVSS score and may be indistinguishable to a cyber operator without the polar plots. However, if a cyber operator is less concerned with maintaining availability for these software services, which is one of the CVSS features, they can remove it. Deleting this feature now makes the middle CVE on the bottom the highest priority one, and that is shown with a redder color. This shows how the polar plots can be used to allow for customized prioritization. One area of future work for the CVSS polar area plots is to implement additional manipulations besides removing a component of the CVSS score, such as increasing or decreasing the weights of a feature or adding a new manually scored feature. To wrap up the talk, here are the key takeaways. Interpreting the details of cyber vulnerabilities is a difficult problem, but important, especially to the end users of vulnerability assessment capabilities. We showed different views created during a design study geared at making vulnerability information and insights more interpretable, with the cluster view using TSNE aimed at context, and the different plots for displaying description, feature saliency, and severity score components. For our next steps, we would like to connect the views at different levels of abstraction in a unified visual analytics system, as well as perform a systematic evaluation of visualization designs by cyber operators. Finally, here's a list of references from earlier in the talk. Thank you for your time.
All right, Kenny, thank you for that talk, and thanks to everyone for the cool paper. I am seeing some questions in chat. Let me scroll up a little bit. Okay. So lots of chatter about this one. So the first one from Leo, Graphistry. Any reason for using TSNE versus something similar like K-means or more recent like UMAP? So obviously TSNE is a choice. Why that particular choice?
So I think I said that in one of the slides in the talk where it's pretty well supported in like data science toolkits and stuff like that. But I would agree with what Leo suggested about looking into something like K-means or even more UMAP. I think one of the other challenges with those plots is that we were only looking at them in terms of the entire corpus of the NVD. But that's over 135, 140,000 CVEs. So I think to make visualization like that more actionable and useful for an analyst, we need to have more like filtering capabilities on the vulnerabilities before even looking at a visualization like that. So I think maybe being able to filter out vulnerabilities by software service and things like that. Just one other note about TSNE is that it can help to capture the latent space too. And so that was something we were looking into when we were doing our latent semantic analysis off of the vulnerability descriptions.
Yeah, very cool. I could imagine the TSNE, given how popular it is, you can imagine people sort of adjusting the encoding space and maybe even developing a mental model of what they're getting out of it. That might be possible.
And in the paper too, we discuss a use case more in depth of how to use the TSNE plot to look into a set of CVEs. So you can feel free to look at that in the latter section of the paper.
Very cool. Very cool. All right. So next question I see in the chat, Steve Gomez, one of your co-authors, planning a question here. Do you see cases where info is transparent but not actually interpretable, like CVSS elsewhere in cyber?
So I would say one area where that can come up is there's like a lot of tools out there that do things like anomaly detection, and they might give you a little bit of information into that there was like an anomaly score or something like that off of your network traffic data, but it's very hard to go into that data and try to actually get any information. Like a lot of them might, give you a little bit of a time period, but even within like a 5-minute time chunk, you might have thousands, if not hundreds of thousands of data points. So
yeah, that's the classic one, anomaly detection not being interpretable. I think people have written papers about that for a while.
I think they
but it would be
a long time.
Yeah, I think it would be great to see follow-up work that kind of tackles or maybe even enumerates some of these issues in the cybersecurity space.
Absolutely.
That's cool. We do have time for more questions. So Marco Angelini question, what about not limiting to CVSS, but also considering additional layers like CWE or MITRE ATT&CK with an @ in it in order to better support the explanation and risk?
Yeah, I think that would be something that would be good to look into. We didn't look at those for this specific study, but I think those are both, especially the MITRE ATT&CK framework and even like the cyber kill chain are both very good frameworks to use in putting tools into more of an operational context. So I think that those would definitely be great things to look into. So thanks for the suggestion.
Yeah, very cool. So yeah, I think that probably wraps it for this, but very cool paper. Wait, are we seeing more? 1 second. Great suggestion. Okay, cool. Well, thanks again, Kenny. So this is a cool paper. Y'all can find that online. So now I'm going to hand it over to Steve Gomez, who was also on the previous paper, but is also chairing the future of this session. So thanks, Steve.
Yeah, thanks, Lane. I just want to say that was not a plant. That was an honest question. So for the second half of this talk, right, we want to get into practitioner space. How do these tools actually get used in the real world? How does that design process actually look when we have operational constraints? So what we have in this half of the session are 3 talks, 3 videos. And we're going to play them back to back, and then we're going to have an opportunity to have a 20-minute Q&A session at the end there. And that'll be great because we can kind of bounce questions off different authors in sort of a panel format. So the 3 talks that we'll be seeing right now are: the first presentation is by Leo at Graphistry. The second will be by Robert at 26 Labs. And the third will be from Younghoo at Sophos. So we look forward to playing those. Please watch these videos and drop your questions as you have them in the chat, and we will get back to the Q&A at the end. Thanks.
Hi, I'm Leo, the founder and CEO over at Graphistry, and today I'll be talking about 100xing visual investigations by embracing GPUs, automation, AI, and collaboration. This is actually an invited talk from the VizSec team, and so I want to thank the organizers for the opportunity to share what we've been seeing out in the field. If you haven't heard of Graphistry before, we work with a lot of analysts, researchers, developers on all sorts of problems, a lot of digital forensics, think security, fraud, IT, but also goes all the way as far as things like general analytics and genomics. And broadly, we're interested in the problem of how do you 100x the investigation process, and which makes us work a lot on the edge of ideas like graph computing, GPU computing, things like that. So for context here, when we work with these teams, and think federal or enterprise teams, they're facing data blowups in multiple dimensions.
So some quick examples, a company like IBM, when they're doing internal security, they have to cover a surface area of about maybe 380,000 or so employees. Facebook, they might want to protect their users, so they have about 2 billion monthly active users. All these organizations are just generating all sorts of logs in their data center from their websites on their devices, and just kind of need to correlate all of them. If you want to kind of have a broader swath of kind of what folks see, when Sumo Logic, which isn't even one of the biggest security management systems, they reported recently that they get about 19 billion events a second, and which translates about 870 petabytes a day. So the good news is to go with that data, there's been a lot of techniques that have been emerging, think on the heart accelerated compute, AI, collaboration, things like that. And while that's good in theory and practice, that's really hard for analysts to use. And so we view this as sort of both a challenge and opportunity for visualization tools. So I'm gonna take you through a few examples here. So the first one I want to talk about is rethinking visualization using GPUs. And so kind of the new normal is you can actually almost assume infinite compute when we're thinking about how to tackle these things. So if you think, if we take a look at commodity GPUs for a regular laptop and maybe a couple bucks an hour on Amazon, what you'll see is something like this, maybe 30 teraflops of GPU compute on the laptop, and 5 petaflops of compute on the server, maybe almost 300 gigabytes of RAM. That's just like one multi-GPU node you could rent. And a pretty thick pipe, maybe 100 megabytes a second going between them if you're in a corporate or a federal environment. So I'm gonna kind of show you an example of this. So here, this is maybe an advanced analyst using something like a Jupyter notebook. This case, we're going to be looking at misinformation. And here, what we're doing a quick visualization where we see a bunch of misinformation accounts, some summaries for each one. And then the interesting thing is we ran something called UMAP to connect the accounts, not based on if they're communicating or not, but if the machine learning algorithm looking at the communications between them or all the text content can almost find correlations based on the text. And so we'll show that. So we're kind of drawing that out. So where the GPUs come in a system like this is on the front end, almost like a video game, we can kind of render a bunch. So maybe for the 5,000 accounts the algorithm flagged, the interesting bit is we have about 100,000 or 98,000 detected relationships or correlations between them. And the front end GPUs can make that fairly interactive nowadays. And then where the interesting bit is we can do something like real-time clustering in the data center and stream the results in and kind of outperform pretty much any other graph visualization system people use today. And this gets pretty important if then I want to start working with it. If I want to do on the fly histogramming, if I want to kind of drill in on some group and kind of start understanding what's going on. Having GPU compute and keeping it all fairly interactive ends up being pretty powerful. Jumping back, I kind of glossed over pretty quickly the machine learning aspect of this. What's kind of an interesting point here is where while traditional graph analytics is great for seeing kind of concrete entities, think about seeing your users, your assets, even actually the events, linking them together, and kind of an intuitive way to work with them. This actually works really great with more abstract and kind of harder notions for analysts that they might be less comfortable with. For example, in that case, we were showing both correlations and clustering, and then on the fly, we were able to basically filter and recluster. In a sense, filtering you can think of mathematically as a sense of reweighting your matrix. You can imagine adding direct manipulation to do training. These are all things that are, for most analysts, may be kind of foreign concepts or kind of sound very difficult, but all of a sudden, graph visualization in particular, we see as a way to make things a lot more approachable. The last example I want to talk about here is the role of automation for visualization. And so when we're working with, let's say, an enterprise incident response team, and you actually look at how they go through an end-to-end investigation, whether it's taking 15 minutes or 2 weeks, there's a lot of data gathering, data cleaning, data analysis. A lot of it's on the fly. And so while the actual visualization part is actually just a tiny piece of that end-to-end process. And so we can actually automate a lot of that. And so I'm going to kind of give you a sense of how, some of the things we think about and kind of where they fit. So here I'm showing something like a standard Splunk dashboard that an analyst might be doing kind of log searches on. And then as soon as someone's looking at an alert, let's say like a device phoning home because it has malware on it, in Graphistry, what we enable the analyst to do is then kind of click on it and jump into a pre-run playbook. And we have our tailored visualization here of like what's going on inside of for that incident inside of the network, and then what's going outside and kind of crossovers, and you can kind of see in color the timeline and thing. But in terms of automation, that was actually no work from the analyst. What happened behind the scenes when, in terms of automation in the large, is that a multi-step playbook was run. In this case, it looks about 11 steps of queries. And then if I kind of want to look at any individual entity that was brought onto screen, or maybe the entities around them, what I could do is I could actually jump back into Splunk to see the individual step and query that was generated to bring in that data for the analyst. And kind of in this case, we're seeing an example of not just the original query, but actually a tool generated query that might be difficult for the analyst to write normally. So if we kind of put that in context of where a visual tool fits for that investigation process, again, in the small, maybe pivoting and query generation, things like that, I think is a very important area going forward. Also working in the large, so in Graphistry, we believe a lot in kind of point and click, record and replay, and just making the visual tool an interface for that kind of automation. And kind of looking ahead a bit, we think kind of catalysts or kind of multipliers for what's possible is figuring out how to incorporate crowdsourcing, program synthesis, AI, things like that into it. So with that, hopefully that changed a little bit about how you think about where the ceiling for visualization is. Graphistry, we think it's an exciting time to be working on things like GPU computing and automation. If you want to try any of this, we actually have a free tier Graphistry hub. So just head to our website and give it a go. And I'll be around answering questions. Thank you.
At 26 Labs, our mission is to invent with purpose through our work creating and deploying innovative technologies to empower critical missions of national security, applying our capabilities in research and rapid prototyping, and developing and deploying systems. Our expertise spans big data, cybersecurity, data science, mobile and embedded systems, electronics, and UI/UX. Most of our 200 employees work out of our headquarters in Arlington, Virginia, but many also work remotely and from satellite offices. Our diverse training and backgrounds enable us to develop out-of-the-box solutions that are grounded in the practical realities of our customers' needs. One of our most prominent projects has been Project Ike, formerly known as Plan X, an end-to-end platform-enhancing cybersecurity operations to achieve better, more consistent outcomes. Notably, Ike makes heavy use of visualization for operation planning and battlespace presentation to mission planners and decision makers. Automated processes powered by machine learning reduce manual effort for operators, and advanced battlespace visualizations give cyber commanders precise, real-time insight into networks. What's more, reporting tools allow teams to track their impact at every step. Our mobile and embedded system work includes the development of privacy enhancements for Android, a platform for exploring concepts and regulating access to private information on mobile devices. PE for Android allows app developers to safely leverage state-of-the-art privacy techniques, and it helps users take ownership of their private information through intuitive controls and permission enforcement. Our work also includes bespoke tools to solve specific user needs.
One example that I'll talk about again later is a tool to help network security analysts identify and investigate suspicious network activity. Our visualization enables easy detection of patterns that would be next to impossible to identify using typical log analysis. We also developed a system to detect internet disruptions in real time by detecting anomalies in BGP route updates. Our dashboard shows these disruptions as they happen and allows users to browse historical events to see how events such as fiber cuts or hurricanes disrupted regions around the world. When Arcus detects a new disruption, it dynamically generates a report and publishes it for analysis. Inventing with purpose is our guiding philosophy, and there are many actions we take and principles we follow to put that philosophy in practice. Two important ones are to know your users and to know the rules, but know when to break them. What made all the above projects successful was clear dialogue with our users. In some cases, we were part of the target user group, which immediately gave us clear insight into the problem and potential solutions. In other cases, we were designing a tool for an external user group and had limited knowledge about their challenges going into the project. But being able to have conversations and adeptly develop a deep understanding of user needs and challenges ensured that the end product successfully served the users. Visualization practitioners in this area are often cybersecurity experts in addition to having data visualization expertise. But cybersecurity is a big tent, and nobody can be an expert in everything. This necessitates having access to target users to discuss the problem and solutions. This is equally important for product developers in industry and academic researchers conducting design studies. Unfortunately, it can be notoriously difficult to find experts who have the time and ability to take part in participatory design, let alone experts who can also share examples of their data. In situations like these, you have to get creative and make opportunities where you don't have them. Troll your social network, make contacts at conferences, and find transition partners who would be interested in adopting a new tool. Knowing your users is a tenet you will find in every UX or design reference, but it bears repeating because it is so crucial for success. You can't propose a purposeful solution unless you understand the problem people need solving. Second, know the rules, but know when to break them. I don't mean this in a ask forgiveness instead of permission way. Rather, I mean that the field of visualization is full of wisdom that can help us quickly identify good solutions, but we need to be clear-eyed about when the conventional wisdom does not apply. In the project I mentioned a moment ago, we were developing a system to automatically detect periodic network activity. My colleague developed a very robust algorithm to detect it, but even though there are many types of malicious periodic activity, such as beaconing to command and control servers, there are also many types of non-malicious periodic activity, such as keep alive services and software update services. We needed a way to find periodic network activity, a task computers are very good at, and a way to triage malicious activity for further investigation and remediation, a task humans are very good at. One might think the visual information seeking mantra would be a perfect fit. Overview first, then zoom and filter, then details on demand. The problem is that what makes some periodic activity malicious or not is not well suited to overview visualizations, which are instead good candidates when you need to find trends, patterns, clusters, and outliers. In our case, the maliciousness is not encoded in the IP or port range, or the period length or regularity of the activity. Instead, maliciousness is often determined based on the idiosyncrasies of the specific network. Periodic activity to an external domain might be fine, or it could indicate malware if the domain is unknown and has a suspicious name. And suspicious-looking activity on a government network might look normal at a LAN party. This information is not directly encoded in the data, which makes overview visualizations difficult and unhelpful.
Instead, we found it helpful to provide analysts with a tabular interface to easily sort and filter on all the information they need to triage periodic network activity. This worked quite well, and we were able to apply our tool on data from many different networks. The visual information seeking mantra is an incredibly useful approach to designing interactive data analysis tools, but knowing that this was a situation to apply a different design allowed us to produce something far more impactful. For me, these projects underscore the importance of knowing your users and knowing the rules, but knowing when to break them. Of course, I would be remiss if I didn't mention that we're hiring for a variety of roles across the company. If you'd like to invent with purpose, come join us.
Hello everyone, my name is Younghoo. I present our talk, Visualization for IP Neighborhood and Email Classification. In this talk, I presented two topics. The first one is IP analysis with Hilbert curves, and second one is email classification with BLIME analysis. I'm a data scientist at Sophos AI, and I research in ML models for email and web contents. Thomas is my colleague at Sophos AI. He researches in ML models for IP reputation. At Sophos AI, we develop ML models, large-scale scientific computer architecture, and visualization tools for information security. The first topic is IP data analysis with Hilbert curves. We developed a ML model to block malicious IP addresses. IP is tied to physically clustered geolocations, and attackers often reuse adjacent IPs which belong to same network. So we need an efficient way to visualize IPs. IP address is one-dimensional, but it is not easy to visualize relationship between IPs. Hilbert curves allow us to render IPs into 2D space where adjacent IPs are projected together. So it is possible to analyze new IPs with their neighboring IPs to discover their relationship. We have two Hilbert curves here. The left one shows how Hilbert render one-dimensional data into 2D space, and the right one is one example of Hilbert curve with Internet IP addresses. We are going to show some real IPs in Hilbert curves. The first one, we collected IP addresses from websites, which include malicious website and also legitimate website. The red ones are from malicious website and blue ones from legitimate ones. As we can see, malicious emails in red are clustered together. Also, legitimate ones are also clustered together. So we can see separations. The next one, we collected different IP addresses from email domains. The red ones are from spam domains and the blue ones are from legitimate email domains. Also, we can see malicious IPs are clustered together. Next, we display only malicious domains in a Hilbert curve. We used IPs from malicious website and the spam emails. The blue ones are from malicious website and the yellow ones are from email domains. There is no overlap between malicious web and the spam IPs, but malicious web
malicious IPs are clustered together. Next, we show our model's predictions in a Hilbert curve. Similar IPs have a similar maliciousness scores, and they are clustered as neighbors. So we can inspect new IPs with neighboring malicious ones in a Hilbert curve. The second topic is email classification with line analysis. We developed an email classification model to detect malicious emails. It is challenging to identify phishing emails which only contain handcrafted short text. We also wanted to understand our models, the reasons behind the detection. Our email model is based on a complex bot architecture, which is kinds of black box model. So it is hard to explain the reasons behind the model's predictions. So it is necessary to inspect our model's behaviors to gain trust from different stakeholders, which include model designers, model testers, and end users. We use LIME method, which is a local interpretable model agnostic explanation approach. The method understands a model by perturbing the input of samples and understanding how the predictions change. The method samples instances close to the target sample and get predictions and weight them by proximity to instances. This way, we can get high-weighted words in email text. For example, this one is a LIME example. Our model recognized this email as benign one, and our prediction score is close to 0. And we display high-weighted words. If the words are legitimate, we display in blue, and malicious words are in orange. And we don't see any malicious words in this email. The next one is a malicious spam email. Our model recognized this one as malicious and highlighted malicious words, for example, transfer, urgent, and payment. Those suspicious words are recognized by LIME. So with LIME, we can understand what are the high impact words in email text. It is also possible to inspect our model's internal weights. For example, our model has multiple transformer blocks, and here we display 3 transformer blocks, and each transformer block has multiple attention sub-modules. And we can see some patterns here, and also if we click one of those sub-modules, we can actually see individual words weight. For example, here, the transfer word has different attention weight between other related words. Conclusion. In this presentation, we introduced 2 tools. The first tool was Hilbert curves. Hilbert curves help us to map a large one-dimensional IP dataset into 2-dimensional space where we can inspect new IPs with neighboring IPs.
The second tool was LIME. LIME analysis helps us to inspect the behaviors of a complex black box model with neighboring samples and provide us model's explainability. Visualization is your best friend for ML data analysis and model analysis. Visit our website for more information about visualization tools for ML projects. Thank you for listening.
Yes. All right, welcome back, everybody. So we're at the Q&A portion of our practitioner talks. First of all, I want to thank Leo, Robert, and Younghoo for those wonderful talks. I think we learned a lot about sort of that nexus between translating research ideas for VizSec into products and how you can develop in sort of a different environment than you might have in academia. So I'll start with a couple of questions, but I want to say some of these might be targeted at individual speakers here. Feel free for the other panelists to kind of jump in and talk if you think something's relevant to you. So we'll start with a question that we have by Huyan, who said, we have sandboxes to analyze malware, for example, hybrid and any run, but their analysis is not interactive and it's mostly text-based. Do you think that the metadata of system activities would be helpful to analyze malware activities within the system? And what is the challenges in visualizing malware that you have seen? So I'm not sure if that was targeted at a specific person, but if anyone has opinions on that and wants to jump in.
Yeah, we've actually see a lot of malware analysis in practice, or actually I shouldn't say a lot, but we do see some, and we get to, I've been lucky enough to see it from folks who have pretty big corpuses, think like, you know, entire world type of corpus. And the metadata is like, just as the metadata is interesting for machine learning. For folks unfamiliar with this type of analysis, I'd like to compare it to like finding who made the bomb. Like, you know, you want to find the fingerprints and like, you want to find metadata around like, you know, timestamps of the compiler tools, all that kind of stuff. And whether you call it correlation, whether you call it like hypergraph or whatever, being able to link together categorical and non-categorical fingerprints is very powerful. And then likewise, if you think of it as like a supply chain problem, where you actually have you know, people making the toolkits, people deploying the toolkits, and then the victims getting kind of accessed on it, there's just so much metadata there that we actually, like, if you want to like analyze like the campaign or whatever, we think actually visualizing that stuff and investigating through it is actually so useful that both the themes of visualization and automation for us is very important there. That might have been an over answer.
I have a related but a little bit of a different take. So I've seen quite a few what seem to me to be pretty compelling malware visualization tools. Some of them, like the one we saw in the keynote earlier, was focusing more on the dynamic analysis of malware samples, and then clustering those or doing other analysis on dynamic analysis. Some other tools have looked at printable strings, for example, or features of the binaries themselves, and for whatever sort of similarity analysis and so on. So I think there's a lot we can do with to help support malware analysis through visualization. I personally have not worked so much with the metadata. The very little bit of time I spent with it, I personally didn't find a whole lot of use from the metadata, because so much of it can be faked, and because it doesn't quite provide you as much rich information, at least about what the malware is doing, as you would get out of the actual binary itself. But I suppose some of that will also depend on what your actual goals are. I've definitely seen some useful visualizations of the metadata for trying to get an understanding of a particular corpus, for example,
is, if you're building a malware classification tool, you probably want to understand, even if the timestamps might not be perfectly correct, is your corpus up to date or not? Are you trying to train a model based on malware from 10 years ago, and the features you're going to get out of that aren't the same features that you're going to see in present day malware?
So just to riff on that a little bit about metadata, and something that you said, Robert, in your talk was that there are cases where some of these features are not so helpful to visualize at that highest level of the information seeking loop. On the other hand, what we heard, I think, in Younghoo's talk was that I think he said visualization can be your best friend when dealing with machine learning for cybersecurity. And I guess I was interested in your perspectives on, when do you go with the visualization route? When do you automate things, which is something that was mentioned in some of the talks also, and how do you know whether you're, I guess, making that proper trade-off of, applying visual encodings to something that might be better suited for machine analysis?
Yeah, I think that the answer, it kind of like was quick, but like I like the perspective of like who's the end user, what is the task that they're trying to do. So if this is like an incident or response analyst just trying to like get through their day, that's one thing. If it's like a malware reverse engineer trying to look at this, look at what's actually going on, they might care a bit about the metadata, but they might care more about like the syslog traces of like running in a sandbox. Or it might be like the threat intel researcher trying to look at the campaign, as I was talking about, to understand, is the financial, like all their financial clients getting impacted. Or it might be the machine learning engineer trying to, tune their model or figure out what the model is doing. They want to look at like how different features are triggering false positives, false negatives. But it's all like the level of zoom, and it's I don't know. For me, it's kind of hard. Like I have very different answers per persona.
Yeah, I believe visualization is a tool for everybody, all stakeholders for a ML project, which will include model designers and model validation testers, and also end users. So even when a model produce very impressive result, it's really hard to validate the reason behind. So yeah, one of the best ways to visualize all the internal metadata or internal state, the state in the model. The efficient visualization, I guess, is the best way to build the trust between all stakeholders, and also you will be confident to view the internal information, which through the model's predictions.
Great, thank you. So we have a question from Marco. This is a wonderful question. I think it probably comes up every year at VizSec, but from a practitioner's point of view, what are the research activities that you can see as being sort of the most useful things that people should focus on in the VizSec community, especially if you were thinking about a younger researcher who's new to the field, where could they make a big difference?
I think there's a lot of room for doing kind of ethnographic research in cybersecurity. I think, as I alluded in my talk, I think there's I don't think we involve enough of the people who are actually going to be using our tools, and I think that also relates to Josh's point in his keynote about there are also there's organizational friction in getting your work adopted. And I think as a community, we need to better understand our users, get those people involved in the design process of the tools that we're proposing that they use, better understand what we can do to reduce the friction to have them want to introduce it into their tool suite, and then also understand what are the what's the organizational friction that even if an analyst wants it, what are the barriers to actually getting it implemented, getting it purchased by the organization, getting people trained to use it.
Great, thanks. So I'll put you on the spot a little bit because you mentioned in your talk, I think, that you have to make opportunities because participatory research is so hard due to sensitivity or getting experts time. Do you have an example or any wisdom about how to go about making that opportunity?
I don't have a lot of great advice. I think all of any time that's been successful, it's just been from having a really broad network of people you can talk to. And sometimes you have to make that network. I've seen people do that by just going to LinkedIn and searching for cybersecurity as a keyword and keep people's profiles, and then sending out lots of links to ask for them to fill out a questionnaire, for example. In other cases, it happens to be that I knew someone who happened to be in a particular community, and then by knowing them, they hooked me up with 10 people, and that was really helpful. I don't have a lot of great advice other than I think just try to get it introduced to as many people as you can who do the kind of work that you're working in or want to be working in the future.
Yeah, I think that's great advice. Oh, Leo, did you want to jump in?
Yeah, so I think the question was any advice for folks trying to break into the field. I think it's actually both questions, you're right, are pretty related. One is there's just so much changing. So I gave the full 10-minute talk about collaboration tech and AI and how do we get regular analysts using AI. And then as part of that, the problem is so big for different kinds of analysts that as soon as you pick an analyst community, you're going to find kind of one of the exciting things about security in particular and security visualization is the problem is so large and so immediate that just by talking to people and just pick any community, and then very quickly they should be pulling you into a lot of their big problems, and they're enough that if you should be able to make a dent, and if not, then it's probably a bad problem, and keep looking. People should want to work with you, basically, and that's a good problem in general.
Yep, that makes a lot of sense. All right, so we got another question. This is for Younghoo. It said the choice of Hilbert curve was interesting. So when choosing visualizations, do you ever have to explain the visualization to the end users before it starts making sense? Which actually that question ties into another one that I had about, when you're working on sort of translating a research prototype and you've got some new interesting intellectual idea, how do you make that work when you go to a practitioner community or a real operator?
Yeah, we often use just, ML models final prediction score as a final product usually. So when we just automated, use it, input data to detect something or block something. But also sometimes it's when the prediction is not, super clear cut. We often support with some additional visualization as a supporting data to our end users to make their own decisions. So for example, the prediction boundary is 50 something around, and our prediction score is 50, around the 60. Then we can provide more additional information. So and the user can finally make their own decisions. So yeah, that's I guess a really good the real use case for visualization tools.
Great, thank you. We've got one for Leo in the chat. It says, any plans to extend Graphistry to allow 3D graphs, for example, in mixed reality or virtual reality?
So stay tuned in 2 months for actually not 3D, but streaming. So you could do live views of stuff. So that's gonna be a lot of fun. And then, ask me in a few months again about the 3D. I did the question about, I actually did like the question about understanding and having to explain, because if you're working with a practitioner, it's somebody's job. So it's okay to take 10 minutes to explain a thing if they're going to be using it for 6 months, generally somebody makes a decision in a day or 2 weeks or whatever. So, and it's fine to kind of walk them through it. Maybe the thing that we found is, again, going to persona, even if you pick something like incident response, just pick one particular job, we found it's really useful to separate the personas within there. You might have the new analyst, it's junior analyst, they really need something quick, point and click.
maybe you have the senior incident responder who's been doing it forever, and then they really want to go in and go deeper. Maybe they know the domain but not how to code, and then maybe there's like that high data hotshot, the new kid or whatever, and they're into kind of doing a bit of the coding, and they could set up dashboards and stuff for that. And if you actually look like a traditional tool like Tableau, understanding the different personas involved in deploying a visual platform and actually building a platform that supports the different personas so they can work as a team is I think that's actually one of the main insights of what made Tableau actually succeed in its industry. So, know your users and talk to people.
Great, thank you. To build on this question that was kind of about how do you start out in the field, how do you identify those high impact areas and get in touch with real operator needs. I was curious kind of from a technical point of view, if y'all had perspectives about kind of what good research areas are at this point. Is the need in the VizSec community right now, is the pressing need about how human AI interaction works? Is it about building better analytics to deal with the data volumes and variety that we're seeing? Are there other kind of technical research areas that you see as being really prominent right now?
Yes.
Could you elaborate? I know that you're got your graph analytics that you would probably talk about here.
Yeah. So I think graph is I think it's not graph for graph's sake, but the things we're trying to solve with graph, and maybe there's other ways to solve it. And so those are for me, it's like, yes, you want to deal with scale, but part of the scale is sometimes they're different methodologies. So is it AI? Is it automation? I don't recall seeing too much about collaboration, but now that's sort of all security work, almost all is done within a team setting, an organization setting, and an open source setting. And so like what is a open source Viz tool? Like what does that actually mean if you have not from people making charts, but people making security insights? How do you do global scale? Like I don't know. It's a really fun time to be doing all this stuff.
This might not be kind of the answer that you're looking for, but I'd reiterate that I think there's I think doing more ethnographic research just to start with, to better understand the people that we're trying to get to use our stuff, the people who have the problems that we want to be solving. I think we can benefit as a community from having more work published in that area, and I think that's probably going to open up a lot of new research problems. Like we can talk about hardware scalability and how do you do visualization on really large data sets, or what's the best way to encode certain types of information visually. But I think better understanding the people and what their needs are as they've been changing. Cybersecurity landscape changes so fast, and probably the tools that they're going to need in 5 years are going to be very different than the tools that we've been building 5 years ago. And I hope we can get some interesting work published on that in the future, because I think that would have a big impact for the community.
So actually, I do have a question for you on that. So like, for example, like I'm wondering, like, so first of all, I do actually strongly agree, like, talking about what does a SOC analyst do versus a hunter do versus like a security software engineer, right? But that's the thing is, like, we're going through so much shift in the industry. So for example, like DevOps and SecDevOps and like automation AI, like I'm wondering, can you narrow that down a bit more of like what you mean from like a research endeavor for ethnography, especially one that won't be stale in 3 years?
Yeah, so I guess what I was hoping is to, we've been talking about how it's so difficult to get partners, get users to talk with, to be design partners, to get information from. And part of the reason why I'm pushing for doing more ethnographic research is that then by publishing that, eventually it's going to go out of date, but hopefully by publishing that information will be useful to a broader group of people. So if you're a particular researcher and you're having a hard time getting more than like one end user in a network operations center, and that's your target users, then you might benefit from having some papers published that are really describing what are the problems, what are the tools they're using, and if nothing else, that could be useful for targeting your work and realizing that maybe you have nothing to contribute in a particular area because of your expertise or what you have access to, and it can help fill the gaps and help you get up to speed and figure out who you should be talking to and maybe how to interface with them.
Great. So we got one question that just came in that said, what do you think the actions should be that VizSec should do to engage more practitioners? Do you guys have any perspectives on that?
I think that's tough. I think that's something that VizSec has always really been part of other bigger academic conferences, and so by that very nature, it's going to skew pretty heavily towards academic work. And I think that's a question that a lot of research conferences have perennially, is what's the right balance between supporting the research community, but then also making sure that you have enough interaction from practitioners, from people who might actually be using your research that you might want to transition your research to. How do you have enough of those people that you can ground your work and make sure that your work is applicable to the real world, but also not make it into a fully industry focused conference and make it something that the academics still want to come to. But then also, if it's more academic, then why would the industry practitioners even go to your conference? What are they going to get out of it? It's not a training session. That's usually what people in the industry are looking for from a conference. Is I want to learn some information I can take back to my job. And if you're doing really, really basic research, it's hard to give them tools that they can take back and use. So I don't think I really have a great solution here. I think involving more practitioners in the research, not just as going and talking to them and figuring out their needs and building a tool, but maybe involving them more as design partners who are actually involved with you in the research and not just answering a questionnaire. I think that might be one way to help bring some people in and gets them involved and invested in the research and gives them a reason to come and attend and see what's going on. But I think there's always going to be that tension of what's the right balance between the research and the applied work.
Yeah, I personally agree. I think that one of the benefits of participatory research is that you have your end user community feel invested in areas of the research pipeline that are helping them. So I have a question. We have a couple more minutes. If there are any other final questions, please remember to drop them in the chat. But Marco made a comment a couple minutes ago that said, collaborative environments for supporting cyber event analysis is an interesting area of research. That made me think of something that Robert said. You were talking about Project Ike and kind of these large battle space visualizations. And I was wondering, whether you think it's beneficial or there are risks to building visualization tools for cyber that give you that really big picture and sort of serve a role as, helping with briefings and explanations. Should those environments be the same ones that let people do discovery and drill into things, or is it better to have some separation in these kinds of tools?
I don't have a ton of experience with the sort of larger sort of higher level sorts of visualizations that you end up using in those larger situational awareness. Think of the big screens you have in the operation centers, in the movies, and so on. I don't have a lot of experience with that kind of situation, but I think a theme that we've had here in the Q&A is having an appropriate segmentation of your users, and that everybody's going to need different tools, even if it's slightly different or at a different sort of scale. So I'd say in general, yeah, they probably are going to need different sorts of things, even if it's about similar data, even if it's presented in a similar way. They might need different visual metaphors. They're probably going to need less interaction, for example. It's probably going to be more static and probably higher level.
Great. Thank you. Leo, did you want to add to that?
Yeah, like I like how you phrased it as like you called out exploratory as somehow feeling different from that. Like I think you're right to think about like kind of the beyond just the role of the user, but the task or the goal of the user, like which you're framing the question implied. So when we walk into like a soccer or knock or something, then we kind of see different persona of like, one is just for the folks in the room, you know, could they have like some broad visibility of like, oh, here's our satellite network, here's our telco network, we just see it. But then as soon as anything actually really happens, then everyone just goes to their laptops or whatever anyway, right? And then like, you know, the big display doesn't, you know, it's a bit useful, but not really. And then likewise, like that big display gets used for something like, if you have like in the security setting, you might have like a CISO tour, like maybe you have like some bank exec who you're trying to sign on as a customer. They get the SOC tour to make sure that you're actually spending money on your SOC essentially. And you get to see the big display and whatever. And so there is value. Some of it's like glitz, some of it's actual just team, whatever. But yeah, like having a one-person exploratory analysis on a shared setting is like what we might see is somebody pull a window onto it or something. But like it generally, like I don't know, it seems like a challenge. And I think you're right to call out the thinking about the function, not just the role, but the function.
All right, I think we're out of time. I do want to quickly note that Elizabeth has mentioned in the Discord that there are some resources for ethnography, so please check out that comment. And I would like to thank you all for your wonderful talks and for participating in this Q&A, which I think was really insightful, and we heard some of these really important themes about understanding users and how to develop useful technology for them. So that with that, I think we'll wrap up this session. Thank you all.
Thank you.
Yeah, thanks for making such a fun session.
Urban motion, illustrating the movement of population from billions of sparse trajectory records. Chang'an Avenue correlates with movement flow. The regions with the largest flow volume. Zoom into the region. The southern Huilongguan region is mostly in blue, cut by G6, which could account for its commuting issue. Rainstorm in Beijing, movement speed is much higher on average. At the remote regions of Beijing, there are few local movements.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. With Tableau, you can keep on asking questions in the data until you discover the root cause. Share your analysis securely. Your entire organization can access these interactive dashboards from any browser or mobile device to find their own answers. Tableau. Answer questions at the speed of thought.
In our talk, we will introduce a didactic methodology for crafting interactive visualizations. This methodology uses a construction kit that describes a visualization using a set of building blocks. Our approach contains 3 successive steps that can assist students and anyone interested in crafting, ranking, and improving new visualization ideas.
Many real-world analysis environments involve multiple types of experts and analysts working together. We aim to provide new knowledge about the role of provenance in a variety of data analysis scenarios. We present the findings from interviews with the data analysts from various domains. Our results demonstrate how different needs for provenance depend on different analyst roles and also helps to identify possible opportunities for advancements and new techniques for provenance support.
We present an exploration into co-located collaborative immersive analytics in a prototype called Fiesta, the free-roaming immersive environment to support team-based analysis. The prototype allows groups of users to visualize and explore their data in a room-scale environment, which we used in an exploratory study involving 10 groups of 3 participants. We focus on the roles which 2D surfaces have, as well as how users leverage the 3D space during both the individual and collaborative work.
DataBreeze is a multimodal visualization system that lets people interact with unit visualizations using pen, touch, and speech. By supporting multimodal interaction, allowing users to manipulate, refine, and customize the view, DataBreeze enables a novel, fluid, and flexible data exploration experience, enabling a seamless transition between global and local level data exploration, spanning the entire dataset or a subset of the data.
Data journalists are a compelling group through which to study data wrangling because they frequently publish their methods to sites such as GitHub. In Table Scraps, we perform a qualitative study of their codes and computational notebooks to better understand the needs and pain points of journalists while data wrangling. From this data, we produce 2 taxonomies of computational journalism and a framework for multi-table data wrangling, and demonstrate these contributions through 2 case studies.
Our paper describes the motivation, ideation, and prototyping of a novel visualization tool to support voice training for transgender people. We centered our design around user needs and lived experiences in order to support self-determination of gender expression. In so doing, we make novel inroads in how to visualize speech data and open possibilities for future work in the design of visualizations that prioritize user agency.
As word clouds grow bigger and words get pushed into the periphery, viewers are less able to accurately compare data, font size for example, associated with each word. This indicates that large distances between words detract from a reader's ability to extract data from the word cloud, but that this bias goes away with the longer periods of reader perusal, suggesting perusal time being an important consideration for design.
Table cartograms are a recent form of data visualization that embed tabular data in a grid of quadrilaterals, like a heat map that has been areaed rather than colored. There are lots of different valid outputs for a single input table. Unfortunately, algorithms found in prior work prevent exploration of this design space. We present a web-ready algorithm for creating table cartograms using an optimization-based approach that supports a wide variety of outputs and aesthetics. Find out more at this address or come by our poster.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. With Tableau, you can keep on asking questions in the data until you discover the root cause. Share your analysis securely. Your entire organization can access these interactive dashboards from any browser or mobile device to find their own answers. Tableau. Answer questions at the speed of thought.
With cluttered or noisy line charts, analysis tasks become difficult, for example selecting the most significant peaks in this data. To overcome this, we can turn to data smoothing. However, many methods are available, and while their results look similar, each preserves different properties of the data. We present a framework for measuring the effectiveness of smoothing techniques on 8 different low-level tasks, and our findings summarize the effectiveness of 12 different smoothing techniques.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau. Answer questions at the speed of thought.
Urban traffic congestion has become an important problem. Previous studies have focused on detecting traffic congestion and predicting future trends. However, it is difficult to find research that identifies the causes of traffic congestion. In this paper, we propose a technique to analyze the cause of traffic congestion based on the traffic flow theory.
We present VRIA, a web-based framework for creating immersive analytics experiences in VR, built upon popular web technologies and enabling the implementation of VR experiences in a web browser, accessible on many platforms. VRIA offers a visualization creation workflow for different levels of expertise using a bespoke builder tool, a declarative grammar, and an API for extensibility. We present a series of use cases along with considerations on performance, scalability, and lessons learned. See you in our talk.
Uncovering causal relations in event sequences can benefit decision-making in various applications. We present an interactive visual analytics system, Kouřil. It incorporates an algorithm with a user feedback mechanism for learning causality in event sequences under the supervision of human experts. It also provides a set of visualization to support causal exploration, verification, and comparison.
We present Uplift, a system that supports casual collaborative visual analytics in the domain of smart grid technologies. We applied a co-design approach to design, implement, and evaluate Uplift with experts in energy systems and members of the Monash microgrid project. Uplift uses embedded data visualization to show energy data for each campus building.
To uncover football tactics, we create spaces and times. We use time query, construct spaces, construct times. Our approach was used for reconstructing team tactics in different classes of game situation. Our domain experts are happy, and the Germans shall win again and again.
Typically, black hole visualization takes a lot of compute time, but we achieve a quite faithful reproduction at interactive rates on a standard computer. For this, we make use of a novel adaptive grid approach to focus calculations where needed. Coupled with filtering and interpolation methods, we can obtain high-quality imagery. Our approach accepts star catalogs and environment maps and generates the resulting deformations in real time.
In our work, we look at how narratives and gamification can be used to foster development of visualization literacy skills in young children between 11 to 13. We present our own instance of such a game, evaluate it in a between-subject study, and report results. We also detail key design considerations for future visualization-based games and highlight many opportunities for future work.
Studies in HCI follow similar steps in explaining hypotheses, laying out a study setup, and reporting results. Many of these decisions are buried in dense scientific text. We contribute a set of examples of how data comics support that reporting, providing an initial set of concrete ideas for how to communicate common stages of HCI studies and statistical analysis.
What is insight? It is a question that has bothered visualization researchers for a long time. We're wondering whether visualization practitioners think about data insights in the same way as visualization researchers do. So we interviewed 23 visualization practitioners to understand how they think. To find out more about what we found and the implications to the visualization community, take a look at our paper.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau, answer questions at the speed of thought.
Usual collaborative systems propose a public and private environments, the latest possessing visibility rights. Subjective views are special objects perceived differently per user. However, a break in the social space may happen during exploration. Our visualization context strives to link efficiently multiple related visualizations together around a common object. We discussed about the designs of a stacking layout, virtual linking layout, and a mix between them.
We propose a localized approach to topological simplification called LTS, which computes the exact same result as the current state-of-the-art simplification procedure implemented in the topology toolkit. But LTS is an order of magnitude faster as it utilizes shared memory parallelism and constrains computationally expensive procedures onto small subsets of the domain. This approach significantly accelerates an essential part of topological data analysis pipelines.
Typical ink displays are in black and white. With the absence of color, we explored texture encoding as an effective way to visualize data. Inspired by existing practice, we summarized black and white texture properties, which can be used to encode data. We developed a prototype of a design tool that can customize black and white textures by manipulating these properties.
In this work, we present an atmospheric model tailored for the interactive visualization of planetary surfaces. Our model provides a complete framework for the absorption of light by small and large particles, such as the oxygen and ozone molecules and Mars dust particles. We demonstrate our results using Earth and Mars as examples.
Ensuring the usability of a dataset is often tied to data wrangling. We can use provenance to log the employed steps, but these alone will not give us meaningful insights if data quality was improved. We propose to incorporate data quality metrics into the provenance model. The enhanced provenance graph can be visualized to show the development of quality throughout the wrangling process. To find out more about the visualization design and the results of our evaluation, please join us during the live presentation and discussion session.
Rendering large volumetric datasets is still a challenge for real-time applications. Wouldn't it be nice if you could just render the dataset at a low screen resolution and your neural network upscales it to the full resolution again? We proposed a network architecture that does exactly that and can outperform a full resolution rendering for large datasets. For quantitative and qualitative evaluations, come to our talk.
Hey everyone, I'm Junhan Zhao, PhD candidate at Purdue University, computer graphics major, and presenting our recent research outcome, Finks Map, an abstract approach to visualize 2D spatial distributions. Due to the conflicts between the limitation of display area and the large amount of comparative distributions need to visualize, the current methods are always restricted. These observations encourage us to come up with a solution by abstracting the visualization.
As visualizations begin to use color, shape, line, and form in new ways, legends often go overlooked as essential to interpretation. To address this issue, we created a web-based interface that renders and formats legend entries, presenting the dynamic properties of glyphs, lines, and surfaces, and increasing nuanced object recognition in artist-driven 3D scientific visualizations. Each legend entry includes the variable name, full value range, and artist-chosen artifact.
Researchers use Argus to determine the sample size based on estimations. There exists a non-trivial dynamic relationship between those estimations and the statistical result and power. Argus allows researchers to explore scenarios of experiment design and effect sizes to better plan experiments.
Atmospheric convection is one of the most important phenomena in meteorology. It is responsible for cloud formation and storms. Yet, the measurements of the convective processes are expensive and scarce. In Isotrotter, we collaborate with a domain expert to build an empirical model of the atmospheric convection based on paragliding data. We design a novel visual parameter space analysis technique using isostructures in the parameter space to explain and validate the model.
Large displays are beneficial for visualizing vast amounts of data. However, there are challenges regarding perception, personalized views, and managing data complexity. To address these issues, we propose to combine large interactive displays with personal augmented reality. We present a design space, as well as several visualization techniques, such as curving the whole screen, embedded visualizations, and many more.
Hi, please come see our talk if you are curious about how to encode your data so that it can be efficiently queried later at different fidelity levels by fetching only the relevant bits from the disk. The talk is titled Efficient and Flexible Hierarchical Data Layouts for a Unified Encoding of Scalar Field Precision and Resolution.
To generate a visual data story, one needs to learn a lot of techniques such as data analysis, visualization, and scripting. To lower the technique barrier, we introduce an intelligent system, Calliope, to generate visual data stories directly from an input spreadsheet in a fully automatic process. Using Calliope, a good visual data story is just a click away from us.
Nowadays, technology is developed for a single audience, assuming that one size fits all. Nevertheless, we all have individual differences, such as personality. Taking into account how personality affects preferences, we study whether it has an effect on hierarchy, evolution over time, and comparison context regarding information visualization. We leverage all personality variables from the 5-factor model and the locus of control with correlation and clustering approaches, showing promising results.
Approximately 100,000 cases of head and neck cancer are diagnosed in the US